Over here we have various collections related to the pterophytes. The pterophytes contain the ferns, and these are the earliest of the vascular plants. So here we can see a fern, not a very big one. All the nice ones we had here kind of died during the shutdown for COVID. I'm showing you the underside of the frond, and you can see all those little clusters under there. Those are the sori. The sori release spores. The spores then develop or germinate into the gametophyte. Spores are always haploid, so what's going to grow from them is also going to be haploid. The gametophyte, called the prothallus in the fern, is tiny. It is microscopic. It contains both antheridia and archegonia. Once an archegonia is fertilized, the sporophyte grows from it. The adult fern plant that you see here is the sporophyte. It is diploid. So in comparison with the bryophytes, the alternation of generations is reversed. The fern spends its time as a sporophyte, as a diploid organism, during most of its life cycle. That's the reverse of the bryophytes, where the gametophyte is the dominant generation. You can actually see some of where the sporangia and sori are from the top side. This is a press specimen of Lycopodium. I have a better specimen across the way I'll show in a bit. This is Psilotum. Psilotum is also called a whisk fern. Very interesting, very ancient organism. See, it doesn't have anything that looks like leaves. The stems are actually photosynthetic. It's still related to the ferns. So these are the earliest of the vascular plants, the pterophytes. They have xylem and phloem that are able to transport water through xylem, phloem for nutrients. Some more ferns. I keep things bagged up because it gets so dry in here. I'm going to show you a better specimen of the Lycopodium over here. And you can see this, what's called the strobili on the Lycopodium. That is where the spores come from. Those large, sort of brownish swellings. We do have some live plants here as well. Just keep them in bags so they don't dry out too much.